Newton's three laws of motion. You should by now have watched the video on the cup and balls experiment, and you should have conducted the cup and balls experiment yourselves and written a conclusion. We're just going to go through some basic theory relating to Newton's laws of motion and the first law of motion, inertia, which was covered in the video relating to that experiment. So this video is all about what is a force. Force is a push or it's a pull. This was proposed by Isaac Newton in the 17th century, and he came up with three laws of motion to describe how objects behave at rest and when they're moving. It wasn't until the 20th century when Einstein came along with his theories of relativity and expanded on these ideas to make the equations more complex, which should be something you learn about if you ever studied physics and relativity at university. The key word in here is that forces cause acceleration, and talking about a net force. You need to exceed the amount of friction holding an object to the ground in order for you to pull it. If you don't exceed the frictional force, the object doesn't move. Once you exceed the frictional force, the object moves forward. For an object to float, the force up needs to be larger than the force down. In order to propel a bicycle forwards, the thrust needs to be greater than the resistance pushing backwards, the frictional force and the air resistance. I want to just make a short video here, so we'll rush through this fairly quickly. In a game of tug of war, if I've got two people pushing to the right and they're exerting 100 newtons, a newton is how we measure force. A newton has got to do with the force of gravity. So on Earth, the force of gravity is larger, and on Mars, the force of gravity is less. But if we've got 100 newtons pushing to the right and more force pushing to the left, overall, there's 20 more newtons pushing to the left, so the object will accelerate towards the left, so there'll be a net movement to the left and a net acceleration to the left. When the forces balance each other out, there's no net movement, there's no net force. And this applies to Newton's second law of motion, that a force is equivalent to the mass of an object multiplied by the acceleration of the object. If there's no net force, the net force is zero because the object's not moving. If the object's not moving, its speed isn't changing, i.e. its acceleration is nothing. Nothing equals something times zero, so the equation will hold true. When this value is not zero, for example 5, that implies that because there's a net force, there must be an acceleration, so this number here must be non-zero. In everyday situations, Newton's first law of inertia is best represented by a car travelling and the four possible forces exerted on a car in a two-dimensional frame. The car being pushed forwards, backwards, to the right or to the left. If you turn a car to the right, you will feel yourself wanting to push to the left to stop yourself being flung to the right. When you turn left, to stop yourself being flung to the left, your body will automatically try and push to the right to counter that force. For every action, there is an equal and opposite reaction. Now, there's some safety features in cars to stop these reactional forces from causing harm to the human body, most evident in a rear-end collision and in a head-on collision. So I want you to imagine for a moment that we're at a set of traffic lights and we're stopped, and then a giant tractor just comes out of nowhere and hits you from behind, pushing the car forwards, causing an acceleration of the car forwards. Because the car is accelerating forwards and you're currently not moving, your body reacts and inertial forces react by feeling a force to the rear, i.e. you're pushed back into your seat. If the force is hard enough, and that's your head and that's your neck, your head will be pushed backwards away from the neck, causing potentially significant harm to your head and to your neck. That's why cars have headrests to prevent your head from moving too far backwards, causing serious damage. So please do not remove your headrest from your car. It serves a very important safety feature in your car. It stops your head from coming dislodged from your neck in the event of being struck from behind by a large object. In a head-on collision, or if a car strikes a tree or a pole, it's the exact opposite. There's a force pushing the car backwards, and so because you're moving forwards, you want to keep moving forwards. So the human body is propelled to the dash, the windscreen, and out of the windscreen, potentially, depending upon the magnitude of the force. So cars have safety features in place, namely a seatbelt. When the seatbelt was introduced in the 1970s, road fatalities halved almost overnight. In recent times, we also have the additional safety features of airbags, which cushion the blow, reducing the trauma caused to the body by slowing the body down over time and over a distance, reducing the impact. So some very important safety features in your car. In head-ons or side-on collisions, we've got seatbelts and airbags to stop us being flung forwards and to the sides. And if we're struck from behind, your head will feel itself being pushed backwards, so we have headrests in our car to stop the head being dislodged from the neck. That's it for today. Please make sure that you have completed your conclusion for your prac report on the cup and balls experiment in the other video. Make sure you address the aim, the hypothesis, state the results, and give a summary point. For example, during this experiment, students learned about Newton's first law of motion, inertia. The hypothesis was supported because the lighter object indeed required less force for the object to remain in or land in the cup. Further to this, it was found that objects with more mass have more inertia. Objects with less mass have less inertia. Takeaway point from today is that cars contain safety features to resist the reactional force during head-on and rear-end collisions, namely headrests in the event of a rear being struck from behind, or seatbelts and airbags in the event of a head-on or side collision. We'll see you all next lesson, where we will be talking about Newton's second law of motion, F equals ma.